$23 an hour.
Healthcare.
Money.
Money.
All right.
Yes.
Yes. Open the law of cosine.
What did you say?
Open the law of cosine.
It is open, isn't it?
No.
Oh, I see what happened. I know what I did wrong. Okay, I'll get that started for you. Okay. Hey, let's talk real quick about what's going on here. Okay. So, I'm hearing that a lot of folks didn't get the assignment done. All right. Let's focus. I feel like most people were on a good track for the first two sets of rules, what was the angle, angle, side, and angle, side, angle. I felt like it was, most of what was going on in class the other day was mostly just sort of careless errors. You know, like not remembering to change the degrees on their calculator, or not being careful about how they rounded and stuff like that. Okay, that with practice that'll get better. So that I'm not too worried about. I think there were folks with legitimate issues with regard to the side-side angle rules. Okay, because that was the third set of questions that you answered that had to do with like, all I wanted you to do at that time was tell me how many solutions there were. There are these rules on page 406 that was how you decide this. What's going on here is these are the side-side angle problems where you are given two adjacent sides of a triangle. Well, all triangles have two sides that are adjacent, and one of the angles, but not the middle one. So you're given a side, and an angle. Okay, well, that might be that the world's greatest triangle. Okay, so an angle. All right, so you've got maybe angle A, and you've got a side, little a across from it, and you've got this side B. But that's all you've got. And you're trying to figure out how to make a triangle here. Okay. So you have side, and an angle, but not the included angle between those two sides. We would call that side angle side then, right? The names have to do with how you're going around the triangle. So side, angle. All right. On this, there are 6 different possibilities. There's a reason why you didn't have an SSA or an angle side rule or whatever back in geometry. Geometry wants things to be perfect. They want them to be these beautiful Euclidean proofs that would make ancient Greeks happy. And this is not going to happen with side angle. On those rules, yeah?
I did it like how I just, because it shows you the, like how you get height.
Yeah?
And then like only one of those fit into like one of those sets.
It should always fit just one. Yeah, exactly. Yeah, hold on. Yeah, well that's like as in what you did in geometry. Like, I mean, Euclid was one of the ancient Greeks who came up with those 5 main rules, those postulates or whatever, that are how you did everything in geometry class. Like, every line, you have a line and a point through a line, there's only one line that's parallel to it. When angles cross, they make the opposite angles are congruent to each other. Those damn rules, that was all that ancient Greek stuff. And they loved perfection. And side angle problems are nothing but lack of perfection. They don't like the fact that there's 6 different ways this could go. But that's what's happening on page 406. In order to make this work, you have to compute this number h, based on what you're given in the problem. Where h is b sine a. And then you just apply these rules. Okay. There is a possible way that this can go wrong. But let's first try where it's not going wrong. So like, for example, if we have a value, let's just say a was equal to 10, b is equal to 8, and angle A equals 45 degrees. All right, then if that's the way it is, h, which for what it's worth, h is the height of the triangle. H is b sine a, so in this case it would be 8 times the sine of 45. And that's some number. Let's just make up a number for that. Let's say that works out to 7. Okay, it's not going to be exactly 7. It's going to be like 6.8 or something like that. All right, so you plug those rules in, and you got that. All right, so we have h equals 7. Hey, is this angle A, is it acute or is it obtuse? It's an acute angle. So of those 6 possibilities there on that table on page 406, we can rule 2 of them out already. Because the last 2 there are for A is obtuse. So we're down to these 4 possibilities left. All right. If A is equal to 10 and H is equal to 7, is the first one the right answer? No, because its necessary condition is that A is less than H. If A is less than H, then there would be none. And like on the stuff that you did on IB Learn, you'd have put a 0 in. There's no answers. Look at the next column. That happens if A is acute and A is equal to H. Is A equal to H? Nope. So it can't be that one. All right. Is A greater than B? Yes, it is. So there's one answer. Let's just look at the last one, the fourth possibility there. If A is between H and B, it's not. That's it. So your answer for that would just be 1. There's just one possibility. Okay. Sometimes there's none. There's no such triangle. Let me give you an example of how there might be no such triangle. What if you had like little, let's see, a giant long side, little tiny side, and big fat angle? Okay, well this, no matter how far we extend these guys, this is never going to make a triangle. They don't ever meet. Alright. The only way that this can go wrong is if the angles they give you are not A, B, like, what if they had done the same sort of problem, but they had told you, oh, well, angle side C equals 10, side B equals 8, and angle C equals 45. Well, there's not even an A in this problem. I wish they had written that table on page 406 differently. Where they say angle A, they just mean the angle they give you. Okay? And where they say little a, they just mean the side opposite that angle that they gave you. Okay? So like if the problem gives you angle B, then you really mean B. Where it says A. Okay? It just means the one that's opposite. The side that you have. I wish they had written it differently, but that's the way they did. Okay, so those problems, it's a little mystery. You just have to riddle your way through those 6 different possibilities to figure out which of them is the right one. It's going to be okay if you need to turn in. I want you to keep doing the stuff that we did last time until you get it perfect. Okay? Because these are going to be relatively, I was going to say easy points. Easy is not the right word. These are points that you can get, and you will get it right with practice. Remember when you were like grade school math? None of it was really all that hard. It just took practice. But then when the time came along in 3rd grade where it was time to do your multiplication problems, and you're learning 3 times 4, you eventually all got it right. Even the dumb kid in school got them all right eventually, right? Okay? You practice 3 times 4 equals 12 enough times, you're going to get it right. Right? This is kind of like that. Even the dumb kids will get it right. That sounds terrible. Bad teaching day, bad teaching day. No, the point is, this isn't that kind, this is the kind of thing where, no, I mean, with practice, you'll just get these right. And so, when we get done with this chapter, we take a test, you're going to get these right. Alright? That's what we're doing. We're just going to practice them until we get them right. And this has been the law of sines. And where we're headed now is law of cosines. Law of cosines is our next set of rules. Hold on just a second here. What's going on here? Sometimes my... So law of cosines, okay, law of sines, the one that we have seen so far, worked for angle side angle, and angle side, and sort of worked for side angle, but we still had to figure out which of the 6 possibilities even was. Notice I never made you go any farther than that and say, oh, now that you know the 6 possibilities, let's say there was one solution, then you would just use law of sines and actually do it. Okay? But I figured by that time you'd already done and gotten perfect 10 problems about law of sines. I didn't make you actually do it, but you could, okay? Once we had that triangle up there and we have done our law of sines and we figured out that there's one solution, alright, now we just start using law of sines and we can solve this thing. Okay? But by the time you get to that group of problems about side angle, you've done that so many times, I didn't make you actually do the math. Alright, but there are 2 more possibilities than Side angle, angle side, all that kind of stuff here. What if all you have is the sides? What if you have a side problem? You've got some kind of triangle here, and you know that one side is 7, and one side is 12, and one side is 8. Notice, by the way, it does not matter how we draw it. I don't really care the fact that my side that's labeled 12 is not longer than the other ones. I mean, it's just that we're just illustrating it to help us picture this. Alright, when you have a side problem, and you need to solve for either angle A, or angle B, or angle C, this is where you start rocking the law of cosines, which starts on page 413. And the law of cosines can actually be written 6 different ways, and rather than make you prove them or anything like that, or derive one from the other, they just give you the 6 different forms of the law of cosines right there. Again, much like law of sines is easy to memorize, but if you didn't memorize it, let me just look here. I think it's in the front of your book, isn't it? Nope, it's not in the front of the book. Maybe it's in the back. Whatever. You will have law of sines and law of cosines on the test. I mean, that's not really the issue. You're not going to, I mean, you'll also have a little bit of geometry and stuff, but whatever. So law of cosines is just a way of relating the sides of the triangles to the angles for side problems, and what other one? Is it side and angle side? Which one is it? Side, and side angle side. Okay. If all I have is the sides of the triangle, there's nothing I can do with law of sines that will help. Law of sines, you got to have at least one angle to make it work. We got to prove the law of cosines when we have this here. Let's just say we're trying to find angle A here. All right, so one of our rules right here will have angle A on the left-hand side. It happens to be on page 413. If you look it over there, it says cosine. It's the top row, the last column. It says alternate form. It says cosine of big A is equal to, and I think it's b squared plus c squared minus a squared over 2bc. Okay. So that's our first little step of using the law of cosines. Figure out which of the 6 forms you need. Whatever you're trying to solve for, figure out which one is, whatever you're trying to find the one that has that on the left. Look it over here. Under standard form, the first one has little a on the left, the second one has little b on the left, and the last one has little c on the left. And then the alternate forms has big A, big B, and big C on the left. So whichever one of the 6 you're trying to solve for, that's where you get it. All right, now you just plug in numbers here, and you get that the cosine of A is equal to 12 squared plus 8 squared minus 7 squared over 2 times 12 times 8, and you get some number. Cosine of A equals some number. Then what do? How do you get back to A? How do you get rid of that cosine? Inverse cosine. So just like we did in other units of the course, that means A equals the inverse cosine of whatever that number was. And then just make sure you're in degrees or radians, whatever the problem is asking for. Make sure you're careful about significant digits and all that kind of stuff. And it just rocks through. Yeah, Brennan.
In the example, they got like negative like 0.45, and then they're like, is given by b equals 106.80. Like, how do they get 106.80 out of that? Like, how they?
Hold on, what are they doing with this here? 116.80. Okay. So wait a minute. So cosine A was, I'm sorry, so look at the problem they're doing there in example 1. So first they found that cosine of B was equal to this. Yeah. And, okay, so cosine of B was some negative number in their problem. Yes. Cosine of B was some negative number. Alright, where on the unit circle is cosine negative? It's over here in this part, right? So your B is some big angle here. Right? Because that's where cosines are negative, is over here. So like, they knew that they were going for an angle here. They're just talking you through the problem there, but let's say they came up with 120 here. All right. So then they used like a different rule to find, let's say they found out that A was equal to 20 degrees, and then they used just 180 minus 20, 120 minus whatever to find the other angle. So they're just talking you through it there. They're just talking you through the reasoning. To be honest, you don't really need to even put that much thought into them. Okay, you just crank them through, they'll be fine. All right, so that's how you do a side-side angle problem. There's also side, side angle. Wait, hold on, what am I here? Side angle side. That's the ones over there. That'd be where you're given a side and an angle. So like let's say we're given that C is equal to A, angle A equals 45 degrees, and side B equals 12. Okay? Well, if we wanted to find this angle, we could actually do that. Let's see here. Hold on. Let's do the example. Let's do the example in their. I got the steps out of order here. All right. Let's do the exact one they have in their in that section on the next page there, because I don't want to get the steps out of order here. So on page 414, example 2. Find the remaining angles inside of a triangle shown below. So they've got A, C, B like this. They've got that this side is 9 and this side is 12. And they've got that the included angle, angle A, is 25 degrees. Okay. And they want to work through how to use these laws to come up with different sides. Alright, so if we wanted to find side A, we're going to use the law of cosines. Alright, law of cosines. We're looking for little a. So we go back on that previous page where there's 6 different equations to choose from and find the one that's got little a on the left-hand side. And it is going to be a squared equals b squared plus c squared. I always forget if it's a minus or a plus. Minus 2bc cos a. Minus 2bc cos a. Alright, we're just going to plug numbers in here. That's going to be 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 45 degrees. All of which is just going to be some number. A squared is some number, so A is just going to be the square root of that number. Whatever the hell this thing is, we now have it. Well, actually, now that we've got that, now we actually have lots of choices. We still need to find angle C and angle B if we wanted to, but actually now we could just do this with law of sines. I mean, look, if I wanted sine of B now, I could just do like sine of B over B equals sine of A over A, because I've got all those things now. And law of sines is actually a lot easier than law of cosines. That tends to be the pattern of these things. You do the law of cosines first, and then you usually have something else you can use, like law of sines, to finish it out. Your book throws one more other idea in here. Gotta keep moving forward on this just quicker. Your book throws in one more idea before it moves on. A consequence of the law of cosines is a nifty little trick called Heron's formula. I'm actually not sure that's how it's pronounced. Heron was an ancient Greek. And Heron was the guy who figured out that actually if you know the sides of your triangle, if you know that this side is 3, this side is 3, and this side is 7, you actually can find the area no matter what. And Heron's formula is pretty slick. And it's given to you on page 416. And it's just that the area is equal to the square root of s times s minus a times s minus b times s minus c. Where s is just, you add those 3 up, and divide by 2. That is the only trick to that one. It's divided by 2. It will hurt very badly if you divide by, doesn't it seem like it should be divided by 3? Doesn't it feel like that should be a plus b plus c divided by 3? It would, but it's 2. Okay. It is pretty straightforward to derive Heron's formula from the law of cosines, but we're not going to do that. But Heron's formula is a pretty neat little trick. As long as you know 3 sides of the triangle, you know the area inside the triangle. This is a big thing, actually, a neat trick that they use in things like land surveying. If you're trying to find a map of, like, trying to figure out how big a piece of property is, you're buying some piece of land or something, and on a map, it's kind of a weird shaped thing. All you gotta do is divide this up into triangles and measure the triangles. And from Heron's formula, you can get this area, and then this area, and then this area, and this area. And no matter how weird this shape is, as long as you can divide it up into triangles, you can find out its area. And in fact, that is how they measure property when you like are buying, a house or something like that, or a farm or something. Anyway, so they give you Heron's formula. It is a consequence of the law of cosines, and they think they're very clever for telling you that. Okay, so today you're going to do problems again, just like you did before. And I'm just about, I had forgotten to actually publish those quizzes real quick here. I'm just going to add, they're called, so here, the law of cosines, these 3 right here. Add them, and we'll put this one to the bottom. Oops, sorry. This one right here. And put this one over here. Okay, so you have 3 sets of little quizzes. They're called law of cosines. 1 are side problems, 1 are side angle side problems, and 1 are Heron's problems. And there's only 3 this time in each instead of 5. Okay, so it should be pretty straightforward to get those guys done without just like pulling your hair out too much and having to redo so many problems. Alright, that is the assignment for today. There's also an exit ticket, but like we did for last time, don't do the exit ticket until you've got this working. Okay? I want everybody to get 100% on the exit ticket because you have mastered the law of cosines.
Actually, I did the exit ticket earlier, and like what I got for an answer was any of the answers.
Really? It's possible. I haven't made the key for that one yet.
I felt like I did it right.
What?
I felt like I did it right, but I
Okay. I can take a look at that. Anytime that happens, if you're like out of the room or whatever, it's something that happens, just send me an email or whatever. Send me your answer and I'll see what's going on. Okay. Yeah, that'll. You mean on one side? Yeah, okay. Yes. I don't want you to actually solve it though. You've already got plenty of practice solving them. For the side angle ones. Right? I just want you to do the business of fitting the how many solutions there are. Well, solving it as in actually coming up with what are the other angles and what are the other sides. Yeah, yeah. Because you could, I mean, that business on that page 406 or whatever that has those 6 possibilities, then you would just put in the value. I mean, all this is telling you is how many answers to look for. Okay? If you plug in law of sines into this, what you're going to find out is that you get like the sine of 1.5. I'm sorry, the sine of A equals 1.5. Well, what's the problem? Sine's never going to be equal to 1.5, right? There's no solution. And over here, this is going to be one of those things where like you need to use both like the plus and you need to use like both the solution that's less than 90 degrees and more than 90 degrees. Well, but you don't do that with those. Okay? Otherwise you just use the one that's cute and it's going to be fine. Okay? But you've already done that to death by the time you get to these SSA problems. So I didn't have you actually do it actually. All you do is tell me how many answers there should be. You could, but you don't have to on that assignment. On that assignment, all you're doing, yeah. But yeah, that's all you would do.
But if I was trying to solve for it,
yes, then you would just plug in law of sines. Yeah, it's just telling you how many answers we're looking for.
Oh, okay.
Yeah. See, sometimes with the information you're given in the problem, there's actually more than one triangle as possible. If you're talking about like an angle side side problem. Let's say you're given that this angle is 45 degrees. This side is 10, and this side is 8. But you don't know this angle right here. It could be any damn thing. Well, actually, if it was swung over here, this could be 8. And you have 45, 10, 8, it'd be fine. Or it could be over this way, and 10, 8, 45, and it would still be fine too. There could be more than one triangle. That only happens when one has the same problems. That's the only ones it happens in. Yeah. That's why the ancient Greeks hated it. They really, really wanted to find a way that could not be the way. It had to work. Yeah.
So, I'm getting to, I already did the first one, so I found out where it was.
You look better.
Yeah. No, I looked over science. And then I'll go over here, and then this one. I got the last one right, so I'm doing the steps right for this.
Is it on here? Yeah, Siri.
What does it tell me? Tell me that there's a long, what is there one? So like, if I go through it, start here. So like I check the bowl, actually go through it all the way through, that's 2 times. I go 2, 2, times.
Okay.
Like I've done all the steps for it, take the square root of this.
Yeah.
Just the thing you need, and then I went and set up my equation here on the inverse way, so we take the sine, because we're looking for the sine of the other one, so we can take the inverse sine of it. So I get the sine of b here, and the inverse sine of it.
Okay. This is number 2 on the first set of problems.
Kansasfun.com.
Okay.
Is it reading it as a reading from?
Let me take a look real quick. You're scaring me on that one now.
Because like I did the one before this, if you look at the other
Yeah.
attempt I did, I was even closer to it, I was off by 0.3.
So the first one was right?
The first one I did it wrong.
Yeah.
The second attempt I did, I was off by 0.3, and then the third attempt I did, I was off by like 0.2, it looks like. So I'm wondering if that's on me or if that's somewhere in your thing.
So you're talking about the second problem though?
Yes, the second problem.
Alright.
Because if it's on me,
Okay, a squared plus b squared minus c squared divided by 2ab. Okay, Ken, why don't you come up here real quick? So the problem is cosine c equals a squared plus b squared minus 2ab. No. It's, well, see, it's just formulas. Minus c squared over 2ab, right? That's the formula you're using. You're trying to find angle c? Oh, maybe, are you on a different problem? Wait a minute, hold on. Are you on side, or are you on side angle? I'm on this.
So, what letter is that supposed to be?
Nothing?
Yeah. And what
Well,
letter
you
is
can,
B?
you can,
What sides are what sides?
well, they're always opposite each other. So big A is opposite
Okay.
little a, big B is opposite little b. Okay.
those are the same side.
Side angle side. Okay, so I'm looking at the wrong one. Okay.
We're looking for how big is angle B.
Okay, hold on.
And you have to
See what you can do.
go off save.
Hold on. Yeah. So,
I did sine first.
okay. Okay, so side angle side. Yeah. Here's what I'm worried about. That. Oh, can you go hit the stop button on that camera back there? Sorry to be.
Which button is to stop?
I don't know. There's only one big button on that.
Big red button.